Okay, class, this video I'm going to focus on transformations of exponential functions, and specifically the domain and range after we do the transformations. And I want to remind you that I am using the app Desmos. You can get that on your phone or your iPad. These pictures are from an iPad app of Desmos. You can also go on your computer to www.desmos.com, and you can use that to look at the graphs. And I think the graphs give you a really, really good visual of what's happening. So I would strongly encourage you to do that. So for this specific question, we're talking about f of x equals negative, and I put 2x, and it's 2 to the x. Our question is saying f of x equals negative 2 to the x plus 1. That's an exponential function. And you definitely want to make sure that that x is the power. So negative 2 to the x power. And it's the 2 that's being raised to the x. Before we can really decide what's happening with negative 2 to the x power plus 1, we look at the parent function. And the parent function here is y equals 2 to the x. And that's what this red graph is right here. Y equals 2 to the x. And I want to point out this point right here. This is my y-intercept. It is 0, 1. And the other point that I want to point out is 2, 4. So we have the point 0, 1 and the point 2, 4 on this graph. And we're going to focus on what happens with those. The next thing that I want to talk about is this negative sign right here. I want to make sure that you realize that negative is not being raised to the x power. The negative is, you can think of it almost as negative 1. So you can think of it as negative 1 times 2 to the x power. Because that negative is not in parentheses with the 2 and the x on the outside, that means that negative is not being raised to the x power. It would have to be written in parentheses to the x power. So negative 2 inside parentheses raised to the x power is when the negative would be raised to that power. And we are not doing that. That negative is completely separate. The only thing being raised to a power is the 2. And that's a super important thing for us to realize as we start looking at this function right here. So the negative, if you remember, is going to be a reflection, and this is going to reflect across the x-axis. And the plus 1 is our up and down movement. So it's going to be moving one way, up or down, depending on the positive or the negative part of it. So the first thing I want us to address is the negative in front of my base that's being raised to the x power. So when I graph the function negative 2 to the x power, I want you to see I had this point, and then I had 2, 4. Those were 2 points that were on. So it has stayed on the y-axis, but it did go to negative 1. So the point that I have after the reflection is 0, negative 1. And then my 2, 4 became 2, negative 4. So those 2 points are good things for you to see once I reflected it, okay? Now, when I look at my parent function, I want you to realize that I have an asymptote right here. My asymptote is horizontal when I'm dealing with these exponential functions. So my asymptote is y equals 0, and that for my parent function affects my range. So for this parent function, because of that horizontal asymptote of y equals 0, my range, my y values don't start until 0. And 0 is not included, so that's why I have a parentheses there. But then I have all my y values, and they go all the way up to infinity. So I have 0 to infinity for this parent function. Now my domain is going to be all of my x values. And if you look at the graph, hopefully you're beginning to see that all x values are included. So it goes from all the way from negative infinity to positive infinity, because this graph continues to get wider and wider as we approach positive infinity. Okay? Now, when I do the reflection across the x-axis, or y equals 0, because the x-axis is y equals 0, okay, all of my values stayed underneath the x-axis compared to my parent function where everything was above the x-axis. So we still have our asymptote right here. The behavior of the graph is just underneath it instead of above. So I am going to now take this graph, this negative 2 to the x power, and I am going to add 1 to it. So the 1 moves our graph up and down. So this point is going to go up 1, and this point is going to go up 1, and my y equals 0 is going to go up to y equals 1. So let's see what that looks like here. So instead of y equals 0 as my asymptote is now y equals 1. So that's going to change the range of my function. So the range of my function starts way down here at negative infinity. So way down here at negative infinity, that's where my range starts. Okay? And on our parent function, we stopped when we hit that asymptote. And the same is true here, that we're going to stop when we hit that asymptote, but the asymptote is at y. We stop when once we approach that asymptote, and we hit that asymptote at y equals 1 because of our vertical movement, which is the +1. So I've got negative infinity to 1, and 1 is not included. So that is the range of this function. The domain of this function is all of my x values. So it's negative infinity to positive infinity, because I'm going to hit all of my x values. Okay? And so that is the domain and the range, and that is the movement of the parent function 2 to the x.